Now we shall discuss about how to do image segmentation via region-based techniques. As we know, a given input image may possess different regions and different features. Here, segmentation is done based on the attributes like color, shape, intensity or texture generally a pixel carries. Ultimately, a region will be formed by accounting with homogeneity measures. So based on the similarities, a pixels are grouped among themselves to form the regions. It is based on the pixel aggregation technique where we need to selectively pick a pixel point or a pixel such that we are going to call that one as a seed point or a base point, and from them regions are grown by applying 8 connectivity neighborhood principle to each seed point here. So you can see in the input image, I am having 6, 0, 3 and 1. So these are my some seed points in the given 8 cross 8 input image. So this seed point is connected with its surrounding pixels by using the 8 connectivity neighborhood. Okay, so if I treat this 6 as a seed point and if we would like to form a region with its surrounding pixels, means definitely there should be a condition that it should satisfy. That is a seed value minus the pixel value, and if this difference is less than the threshold, the region will be formed ultimately. That is if 6 minus 7. Okay, so if 6 minus 7, if it is less than the threshold, let me take the threshold value as 1. So 6 minus 7 is less than, okay, let me go with a threshold value of 2 here. So 6 minus 7, which is less than 2. That means these two pixels are ready to form a region. So to explain this case in better way, let me have this as an example where I am having here a 5 cross 5 input image such that I picked a seed value as 6 here and kept the threshold appropriately selected as 3 units. Now the condition where I can able to expand the region is seed value minus the pixel value is less than the 3. So let me start from here. So the 6 minus 6, because this 6 is surrounded by its neighboring pixels by using the 8 connectivity principle. So 6 minus 7, which is less than threshold. That means these two pixels are having a capability to form a region. So these two comes under one region. Similarly, check the seed value with this pixel. Also check with this pixel and all the pixels this seed value is being surrounded with. So if the condition is satisfied, that means all these pixels are having a qualification to form a region with this seed point. Now you are going to apply the same by considering this one into account. Now let me assume that if this is the seed point now. So this seed point is connected with its surrounding pixels by using the 8 connectivity neighborhood. So apply the same concept here. That means 6 minus 2. If it is less than 3, no. 4 is not a less than 3. That means this pixel is not ready to grow a region with this pixel. That means this 2 is in some other region and this 6 is in some other region. So for each and every pixel you can apply the same condition here, and if it is satisfying, that pixel is want to mingle with the seed pixel here. Ultimately they form a region. This generally happens in the region growing segmentation. So adding the pixels to the seed point, where if the condition is true, that means this condition I may call it is a predicate, and if that predicate is true, I can able to expand the region. So this expansion is done based on the condition is satisfiable. So this region can be grown until the condition is true here. That means the predicate is true, where we need to repeat up to all the pixels are segmented in the given input image. So the same thing you can see here. So the ultimate result after the region growing segmentation technique is this one. So after that means you can see these ones comes under one region here. So these three comes under different features and these three comes under different features. These three are nothing but here the zeros. Okay. And these three zeros are comes under different region or different features in an image. And similarly these three zeros also. So that means in aggregately I can say that this 5 cross 5 image is having 5 different regions or 5 different segments it is possessing. So let me label each and every segment or region now. So let me label this segment or region with A and all the ones are comes under the one region. So let me label it with B and this is my C and this is D and this is the E. In this way the region growing process happens. And the next technique we are going to study here is region splitting and merging technique. So what is this region splitting and merging technique here is, so to start, what I will be doing here, it is generally treated as an opposite approach to the region growing technique. So that means there the region is grown in the earlier technique. But here the region is splitted. That means shrinking of the region happens. So first thing is I assume that my entire region of the image or my entire image is a homogeneous with nature, by nature. So if this is not true, the image is splitted into 4 subparts or 4 different regions like this. Okay, so the same thing I have done here, and this splitting is repeated and successively until we split the image into some homogeneous region. So you can see here this is my input image. Okay, so I have splitted because I cannot find the homogeneity in all the regions in the image. So I have splitted. Now I have splitted into 4 equal parts, R0, R1, R2 and this is my R3. Still in the R0 region I can find each and every pixel are homogeneous with each other. So I am not going to split it anymore. Coming to R1, I need to split because all the pixels are not carrying the homogeneity property. So let me again split this R1 region into 4 equal parts as R11, R10, R11, R12 and R13. So after that one R2, this region is possessing the homogeneity or alike in attributes. So I am not going to split this region. And coming to the R3 region, again some kind of dissimilarity I can observe or sense here. So I definitely have to split this region for further processing. Ultimately, I can sense that R0 and R2 are the two regions which have the same homogeneity in its pixels attributes, right? Coming to R1 region, so R1 as I have splitted, right, as R10, R11, R12 and R13. Again, I am going to check the R10 region. So this region is having some kind of dissimilarities among themselves. So again we are going to split like R10, R101, R102, R103. So in this manner it carries. So the splitting procedure is repeated in this manner successively until we split the image into some homogeneous region. Okay, now consider this entire image as homogeneous. Okay, the first thing what we need to consider is we have to start by treating any input image as a homogeneous. If it is not true only, we need to divide the image into the corresponding regions, right? So let me see one more example here. So if a region, let me call this region is this entire image is a unique region R. If this R is non-homogeneous, okay, that means the condition is false. The predicate is false here. Q of Ri is false, where Q stands for the condition is false. That means it is not a homogeneous. So what I will be doing, I will be splitting this entire image into the 4 subregions like R1, R2, R3 and R4. So R1, R2, R3 possessing the same homogeneity among themselves in the region, but coming to R4, it is exhibiting the dissimilarity among its pixels. So I need to split it into again 4 successive regions as R41, R42, R43 and R44. So that means here when no further splitting is possible, okay, because I have no chance to split it further, for suppose I will start merging technique. So splitting technique is completed successfully. Now I am going to start the merging technique. So merge any adjacent regions, like you consider this is one region and this is one region, for suppose RJ and RK, and you are going to merge these two regions when those two regions which are carrying the pixels shows the same or the alike attributes among themselves. For example, you can see this is one region. This region is indicated with R0 and this is R31 as the region. So when the condition is true, that means whenever the union of these two pixels are exhibiting alike characters, which may be color or shape or texture or some intensities. So if any of it is correct or if they are true, I can able to merge these two regions and these two regions also like R0 and R13. In this manner, I can perform the merging operation. Let me take a small example here. So you can able to see I am doing here a split and merge technique for the given 4x4 input image. So for this 4x4 input image is having different intensity values. So it is in a 4x4 matrix representation, which is if I find that this image is possessing a non-homogeneous character or non-homogeneous regions are present in this image. So by seeing or by observing the different variations in the intensity values, I can feel that this image is carrying a dissimilarities in its features or the regions. Now let me assume the threshold appropriately. I am selecting the threshold as 3 units here. So when I can able to split, so I would like to demonstrate the working principle of how to split or merge a given input image now. Now assuming the threshold for this input image as 3 units, when as we have a condition in the region growing segmentation, some condition also have to be adopted here. That is, higher value pixel minus lower value pixel should be less than the threshold. You can see in this image the higher value pixel is 7 and the lower value pixel is 0. So 7 minus 0, that means 7. If it is less than or equal to 3, is 7 less than or equal to 3? It is false. Hence we need to split the input image into 4 regions here. That is R1, R2, R3 and R4. I have split it now. Again, so applying the same rule for each and every subregion. So apply the same rule here for R1 region. So for R1 region, the highest value is 7 and the lowest pixel value is 3. 7 minus 3 is 4, which is 4 is less than 3. It is false. So that means again I need to split into equal regions. So R1 is further undergone into the splitting part. So R1 is splitted again into 4 regions here or 4 boxes. So now check with R2. So in this R2, 6 is the highest pixel value, 3 is the lowest pixel value. 6 minus 3 is less than or equal to 3? No, because 3 is equal to 3. So not required. Any splitting activity is not required for the R2 region. Coming to R3, so highest is 4, lowest is 0. 4 minus 0 is less than 3. It is false. Hence, splitting is required here. And coming to R4 region, highest is 4, lowest is 1. So 4 minus 1, 3 is less than or equal to 3. So we no need to split the R4 region. In this way, the splitting completely happens to a given input image. So as soon as the splitting activity gets completed, we need to merge the input image here. So how to do the merging operation then? So in the process of merging, we need to consider, that means R2 is one region, R4 is one region, and R1 and R3 are divided into subregions here. So coming to the technique, that is merging technique, here merge any adjacent regions where Q of, that means predicate, is true. Okay, so that is, there will be also a condition, that is maximum pixel value of one region. So if this is my one region, right? So let me assume this one. So this R1 is divided into R11, R12, R13 and R14, which carries 4, 3, 6 and 7 as its value. Now maximum pixel value of one region minus minimum pixel value of some other region. Okay, so in this region, the maximum value is 4 and the minimum value is 4 because this is single pixel. Okay, let me go with some other thing here. So this is one region, right? 3, 3, 6 and 5. So the maximum pixel value is how much? It is 6 in this region. So I need to pick one more region, that is the neighboring region. Let it be 3. You can see here. So maximum pixel value minus the pixel value from this region. So 6 minus 3, how much is the difference? 3 is less than or equal to 3. But it is true. Okay. So what I am doing here is, I am merging or I am adding this pixel to this region now. So this happens. Now again, this 3, this 3, this 3, 6 and 5 comes under a single region here. Now in this, among the 5 pixels, 6 is the highest pixel. So 6 minus the pixel value of the adjacent region, that is 4. 6 minus 4, 2 is less than 3. Of course it is true. That means I can merge, I can add the pixel 4 to this region. So 4, 3, 3, 6 and 5 forms a region here. Now we'll check for this one, this 6. So this 6 and with this region, this among the pixels in this region, 6 is the highest value. So 6 minus the intensity value of this pixel. 6 minus 6, 0. It is less than 3, of course. So this 6 is also added to this region. So we need to perform the process for each and every pixel here. In this way, the merging technique happens. So ultimately, finally, it given me the result. That means this input image is having 3 segments. So 3, 4, 6, 4, 3, 3, 3, 6, 5, 4. This comes under one region. 2, 1, 0, 1, 2. This comes under one region, and 7 is coming under some other region. In this way, the merging technique happens. Only the condition for splitting is higher value minus lower value. If it is less than the threshold, what we have to do? We no need to split. If it is greater than the threshold, we need to split. And the condition for the merging is maximum pixel value of one region minus minimum of some other region or adjacent region or whatever it is. If it is less than threshold, we are going to merge that following region here. Okay, so the same example here I would like to project. This is my given input image. After doing the splitting operation, this is the resultant image, and successively followed with the merging technique, I got this as an output. So you can see here the image is divided into many number of pixels, and based on the similarities, these are grouped. Okay, finally this is the result of the split and merge technique. So it is your job to apply the principle of how to do the splitting and merging operation for this input image, and finally how you are going to obtain this one as an output. That means This input image is having finally 1, 2, 3, 4, 5, 6, 7, 8. 8 different segments or 8 regions inside it.